check your understanding problem. It says a person on an oil drilling ship on the Gulf of Mexico sees a semi-submersible platform with a tower on top of it. The tower stands 130 meters above the platform floor. So right away, you're thinking, I have to use this number, 130 meters. Where, on what side of the triangle do you think that 130 meters goes? If this is your triangle, can you just move your arrow to where you think that it goes? Right here. So let's go ahead, let's label that. All right, so I'm going to type it in. I know you could type it in. We're going to type in 130 meters, okay? So that takes care of all the important information that's up here. Okay, so we're kind of done reading this part. So let's just give it a check. We're done. All right. Did you think of that on your own when you were doing the problem? Give me like a up and down for yes and a side to side for no. Yeah, okay, cool. So that, I think that you'll find that's like something that would be very helpful. So I'm just going to slide this up again. If the observer's position on the boat is 15 meters under the floor of the platform and the angle of elevation to the top of the rig is 21 degrees. So I think the 21 degrees is labeled right here. So let's put that in. That's 21 degrees. Okay. And then it says here the angle of elevation to the top of the rig is 21 degrees. Okay, so this 15 meters. So that has to go somewhere. So the 15 meters, so the observer I think the observer is like down here, right? He's 15 meters under the floor of the platform. So I think that means that it's like down here is 15 meters, if that makes sense. Like if this is like the floor, right, along here. What three distances can you find? So it might be helpful to right, like something like that. So when you're going to do this, it's asking what distance can you find, and I didn't say find them. I should have said find them, but I guess I didn't type that in there. So you could find, like if you have this triangle right here, let's just say we have this one right here, boop, 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 right? And here's your triangle, and here's 21 degrees. Okay, and you know this is 130 meters. Okay, can you find what's up here using SOHCAHTOA? Yes, you can, right? Okay, so, yes, and then no. Yes, you can, right? Because you know, if you were going to label the sides, you know that this side right here is the opposite side. Okay, right? Okay. So, and you know this is the hypotenuse side. Right? So what trig function would you use when you're doing, if you're trying to find the hypotenuse side, if you're thinking about SOHCAHTOA? Undo that. Yeah, you would use sine, right? Okay, so you would use sine, so SOHCAHTOA. All right, so you'd use sine. So you could set up an equation that would say sine of 21 degrees is equal to, like I can even type it in. So you could set up an equation. You could say I could find the hypotenuse, right? So I can find the hypotenuse by solving what? Sine of 21 equals what? 130 divided by the hypotenuse, right? So you could find the hypotenuse is the distance. This is the distance, the diagonal distance between the boat and the top of the tower. Okay? You could find another distance. All right, it says find three distances, so you can find another one. So we have the opposite side and the hypotenuse side, right? The other side we know is right here. Can you, what side is this called? I think she's typing it into the chat box. Yeah, she's typing it in. She's typing it in for us. Good, perfect. So she just typed in adjacent side. So you could find the adjacent side, right? So just to kind of keep it moving with this, you could say I could find the adjacent side by setting up another equation. And the adjacent side would be the distance between the boat and the base of the tower, the horizontal distance, right? Okay. And then it says, what 3 distances can you find? So that was one distance right here, another distance right here. 1, 2. I mean, you know this distance. I'm going to change this to just say 2 distances because I think they're looking for, you could also find this distance that's down in here, right? I think I'm just going to change that to 2. So just to talk about part B, so this says the boat moves the observer is 200 meters from the center line of the tower. So that's just drawing a new shape, okay? So here's your tower, and here's the boat, okay? And your new shape, it would move, right? So now it's at 200 meters. 200. Let me move this up just a little bit. Move it up. So it's moving, so this is 200. Okay. And you want to know, what is this angle? Well, the tower didn't grow or shrink. The tower is still the same distance. So this is where you're going to be using one of your inverse trig functions to solve it. That's what this unit, this little lesson is all about. Cosine inverse or tangent inverse. Okay? Which one do you think you would use if you're looking at this angle and you have this side that's on the other side of it and this side that's next to it? Sine inverse, cosine inverse, or tangent inverse? You don't know? What 2 sides do you know? Let's type them out. We have what? Let's put them in alphabetical order. Adjacent, opposite, hypotenuse. Which sides do we know? Can you circle them? On this triangle, which sides do you know? So 200, what's 200? Is it the adjacent, the opposite, or the hypotenuse? Adjacent, so we know adjacent side. What other side do we know? Yep, is that the adjacent? Is that the opposite or the hypotenuse? Yeah, opposite. Perfect. So opposite. So which one of these deals with the opposite and the hypotenuse? The sine inverse, cosine inverse, or tangent? Tangent inverse, right? So that's all you would do, right? You would just say tangent inverse of the opposite side over the adjacent side. All right? All right, give me a yes or no here. You feeling better about this? Yes or no? Okay. All right. When are you gonna? Good. Okay. So we're gonna wrap that up.